Hi, my name is Evan Olo, and for this project I chose to create and build an electric motor. I used a D battery, 2 paper clips, magnet wire, electrical tape, sandpaper, and a neodymium magnet. I used the Science Buddies video on Canvas to help me guide in the process, which I will link at the end. To begin, you bend the paper clips out and extend them so there is a little hole for the wire. Then you tape them to both ends of a D battery. You then create a loop of coil wire and leave some slack on both ends. Rub off half of the insulator on one side of the wire and all of it on the other side. You then put your wire in those little holes in the paper clips above the battery. To finish, you place the neodymium magnet on top of the battery and under the wire. The wire should now rotate like a motor. The process of making the electromagnet was very tedious. I found out that the paper clips were too small and I didn't have enough room for the wire to spin. This caused me to then extend the bottom more so it could work. The way that this electromagnet works is pretty cool. The battery has a positive side and a negative side. When I put the magnet in the middle and place the wire above, it creates a rotational motion and the wire spins. Electromagnets are pretty interesting as they have the ability to create a magnetic field around the wire, making the metal temporarily magnetic. One example of an electromagnet in everyday life is with speakers. In this picture, we see a basic diagram of how they work. There is a base permanent magnet that is next to iron with coiled wire wrapped around it. If a current passes through the wire, then the iron electromagnet will turn magnetized and will be pushed and pulled to and from the permanent magnet. The cone on top will create sound from the vibration due to the moving electromagnet. Another example of an electromagnet in everyday life is magnetic resonance imaging, also known as MRI. To conduct an MRI, the patient is placed in a cylinder that has permanent magnets, electromagnets, and coiled wire all around. Radio frequencies are used to then give energy to hydrogen atoms and allow the coils of wire to detect the energy. This causes a detailed image to be seen. One last example of an electromagnet in everyday life is in computer hard drives. There is an electromagnet in the read-write head that writes information to the disk by magnetizing small sections of the disk. This allows for large amounts of information to be stored in the hard drive. Another very important thing to note is how electricity and magnetism are interconnected. There are a few ways, but one that I find the most interesting is that both electricity and magnetism need conductive metals to travel. Examples of conductive materials include iron, copper, steel, nickel, and more. From a lab we did in class, we used an iron nail with a copper wire along with a battery to make a functioning electromagnet. Since all these materials are conductive, it is clear that magnetism would have not traveled without them. Additionally, the reading from the CER packet states that copper contains loosely held electrons, but those electrons start an electrical current when the wire is moved with a magnet. This magnetic field can be used to create electricity. A third source to prove the interconnection of magnetism and electricity is a SciShow video, where we are told that the magnetism of an electromagnet will not stay if the battery is removed, thus removing the conductive metal. Thank you for watching my video. Hopefully it explained everything that needed to be explained. Have a nice day.